Alright, now we have one more drill bit to do, and it's this one in the center. Now it's debatable whether you do it from this side or the other side. I would prefer to do it from this side, and the reason, two reasons. One, you can go past, and if you have enough length on the drill. Sometimes this is where an extension to the chuck can go, or the extension is smaller than the diameter of this big bore, but it gives it rigidity for this drill sticking out. The tolerance of this isn't all that critical. There's some loose area on it, but concentricity is important. So if we cut it from this side, we know the bushing that goes in here will be concentric to this hole. And if we have enough drill bit length, we can poke through the other side so that when the parting tool comes off, we don't get a weirdness there. Okay, and then we can also use that hole to fixture and indicate center for these milling operations. So I'm going to make the case we're going to go ahead and do it. And it also clears out a little bit of the bottom of this bore so it doesn't need to be machined. Okay. So we're going to do one more copy. We're going to duplicate this drilling cycle, and we're going to go edit. And it's going to be very similar to the last one, but we need to select the correct drill. Okay, I'm going to elect for the 98 thousandths drill, which is number 40. Okay, on this tool, I'm going to slow it down a little bit, 13 inches a minute. Not 90. I think 13 inches a minute might be a little fast. The only part of the hole we're selecting is this one face there for the small part of the hole. And then we're going to go on to the next tab. If we're going for model top for our feed height, but we're going from hole top to hole bottom, in this case we can break through and we can go the extra 180 thousandths if we have a long enough drill bit. Okay, we're going to the next tab, and we're doing deep drilling, but the drill is significantly different in size. So we got a 0.098, we're going to divide that by 2, which gives us about a 50 thousandths peck. Let's hit accept. Alright, and we should have kind of a port looking feature like this that hollows out the part. But you can see how much material needs to be removed between the gray sketch and the orange. So there's a significant amount of material that needs to still go away. Okay, now we need to go in and we're going to bore the highlighted surfaces with a boring bar. Okay, so those, and then when we're done with that, we can come back with a grooving tool to put the 2 grooves in. So it's going to be more, typically it's going to be more than one routine. Otherwise you're going to be machining off more material than you need to. Okay, so we're going to do one routine that will take our bore down to the first step, then another routine it'll take it down to the next step, and then our last one will have parameters for this final step. I intend to use the copy of the internal profile here from our other part number. I'm going to duplicate it though first, because the parameters were set for a very small bore, which is very similar to the last one we're going to do. So we may need to keep the parameters for that as a reference. Okay, so let's start off with the first one. We're going to go edit. Okay, and our first thing, and I want to note there was a mistake in the tutorial for this tool, building this tool, and you might have caught it in the last part I modeled. It will not affect the last part that was in the tutorial, but you should have your boring bar should be thin like this, not a big rectangular block. Now the real cutter, again, does not reflect this at all. It's not an insert cutter, it's solid ground, it's actually round. HSM, I selected the box that said round for this, and it still models it square. So, but it really doesn't matter as long as the toolpath that's generated puts the correct point from the center line in the program. I think 40 inches a minute was pretty optimistic for this tool. regardless of what the conditions are. So I'm going to lower that to 20. And we're going to go to the next tab, which is confinement. We're going to leave it at default. We need to have values in here. So we're going to go 0.01, 0.01, and I believe those need to be negative values because we're currently an interior feature. And then we're going to move on to what's our outer radius. So it's from selection, our outer radius is going to be one of the larger diameter. And then our inner radius, we're going to set that as, is going to be this bore, but then we need the difference between the drill bit that we used and to rough this out in reality. So the finished diameter is 570 thousandths for that surface we selected. So we're going to take 0.57 and then we're going to subtract our tool diameter. .5625. We put that in brackets and we're going to divide it by 2 because it's a radius, not a diameter. Okay, so we don't have a lot of room, but we've offset it by -3 thousandths. Let's actually round that up to 4. And that'll make sure we clear. Okay, we're going to the next tab. Yeah, we do want roughing passes and finish passes. And we do want to use wear compensation. 40 thousandths is scaring me a little bit with this cutter, so let's ratchet that back to 30 thousandths. And this bore is not that critical, so we're not going to repeat the finish pass. No stock to leave, we don't need smoothing on, they're pretty straightforward profiles. And then we're going to go to the last tab, retraction. 80 thousandths might be a little bit too much in the space we have. So let's set that at 30. And 30. And we're going to set this at 45 degrees. We get a couple rough cuts and then a finish cut that comes in and cleans up the bottom of this bore. Okay, we're now ready to move on to the next one. So we copied this boring cycle to be contour number 5. And so we're starting with the same settings. So on containment and model and rest machining, we're not going to select anything. We're going to go to the heights tab. -30, -30. And then the faces we select are going to change. Our outer radius becomes the bore that we're actually cutting. And the inner radius becomes the next smallest bore. Now we're going to go to the next tab. We don't want to allow grooving. We have roughing passes. This pretty much is the same as the last operation. And then on the last tab, okay, we don't want to have a 45 degree lead in. It's going to try to come in some cases on the wrong side at 45 degrees. So we're going to change this to 90 degrees from 45. We can leave the same and same, and then we can accept. Okay, so we've now turned this next step down. We've got subsequent roughing cuts and then a finish cut coming out. Now we have one more bore to do for this hole. Okay, so this is this profile that we copied from the other file that was the finished part. So we want to edit this one, and hopefully we don't have to change this one very much. Okay, so we're going to slow the feed rate down to 10 inches a minute because this is a critical bore. I'm going to go to geometry, and we're not going to use any containment. We're going to go to the next tab. This tab, we need to remember these values that are plugged in here. So we have 0.01 there. We're going to copy that. And our from selection, I believe, was the outside of the part. And then the inner radius was just calculated from the outer radius, but negative 0.005 from it. And so that way we have just a very minimal retract on this. We're going to go to the next tab. We're going to leave a lot of this at default. But I do want to do a repeat on the finish pass in this case, and that's what's called a spring pass. So it cuts at the same number as the previous pass, but it compensates for any flex that's in the actual tool itself. Okay, we're going to go to the next tab. And I'm going to reduce this value to 0.015 for the minimum retract. And our lead in is going to be the same. And with a 0-degree lead. Okay, let's hit accept. And so we lead in, we come to the bottom, and that's as far as it goes. For the size of the tool that's going in there, it's just barely bigger than the diameter. Okay, so we're coming to the close on the turning of this part. The last operation is to part it off on the outside. So we're going to go to our turning part that we copied from the other file. We're going to go edit. We're going to go to turning. We're going to keep the same tool. We're not going to do anything on the second tab. And we're going to go from the model OD, which is here, to a selection, which is going to be the hole that's poking through here. So we're going to select that. And we're going an extra 10 thousandths deeper. Now we're going to probably end up with a little bit of material left on the stock, but we've been facing these off every time anyway. So that should be good. And we can accept the toolpath for that. Okay, we have one more operation to do, and it looks like I did our turning part to remove the part from the stock a little premature. Okay, so I neglected to do these two little grooves that are on the inside for the O-rings prior to the parting. So we're just going to go ahead and we'll highlight the segment before, and we're going to go turning, single groove, and we're going to select from the lathe tool library tool number 12. Now it comes up by default red because it's saying, hey, you want to do an inside groove, but you have an inside groove tool, but we're defaulting to machining on the outside. So we're going to select the box that says machining on the inside, and we'll leave the speeds and feeds at default. And the grooves we're going to select, we're going to use our sketch. I had problems with the model auto selecting the depth. And we're going to offset to the middle because we selected the line and tip. Okay, now we need to set our retracts, and the defaults are for an outside turning. It would be really nice if they upgraded the software so when you selected the box at the beginning saying you're working on the inside, it automatically flip these for you, but it doesn't. Okay, so we don't have 400 thousandths to move inside this part. It's only an inch in diameter, and the hole is only 600 thousandths. So we're going to change that to 30 thousandths, a 32nd. And we don't want to have our retract based off the outside diameter of the stock. In fact, we need to put a negative in front of this. And so we're going to base our retract off the inner radius. So we're going to change this to inner radius. And then we're going to change that to negative 30 thousandths as well. And then our outer radius is not the outside stock. It's going to be from selection, and we're going to pick the bottom of the groove as our outer radius. And so that's the largest diameter we'll be cutting. And then we're going to start from an inner radius from selection, which is going to be the largest diameter on the bore. And so we have our retract and our clearance planes here inside the part, right, like they should be. Go to the next tab, leave everything at default. Go to the following tab, leave that at default, and accept. And there's our toolpath. We've got our blue line coming in. This cutter has a radius on it, which is actually what you want in a O-ring gland. And the cutter is a little bit smaller than the width of the slot, but it'll be within tolerance. Okay, so the only thing we need to do is change the sequence to moving that to occur before the parting operation, and we're good to go. Alright, so now we're ready to move on to Op 2, which is done on the mill. And now let's move on to the milling. Now for the milling, we pretty much have to drill and ream these two holes, and then we need to pocket this and drill this single hole here. You could do these in two different sequences, but I'm going to suggest that we do these two holes first, because right now at the state the piece is, it's symmetrical around center. And if we drill these two pins holes, we can use those to clock the part so that the pocket is in the same orientation. And we need to be careful with these holes. You'll note that they are flat bottom, and in the cross-section view on the drawing, if you were to have a point on those, this hole will bust through into this pocket. And that's not what we would bust into the pocket. And the lower one would bust into the pressure chamber, which would not be good either. So we need to mill these two holes, and we're going to use, and then come back with the reamer to make them the correct size. So this is where that 1/8 inch end mill will be recycled. Okay, so from the that we used on the 127. So we'll use that same tool. We've already got this hole established, so there's nothing to do there. Okay, so let's do it in that order. Let's start a new job. And this one's going to be milling. This is going to be the S60-101 Op 2 for the mill. Control C. Control V. So I copied it down to the bottom. I'll save us a little time there. Okay, let's scroll up. Now our stock is cylindrical, and the cylinder that it follows, of course, is the outside diameter of the part. Okay, we're not going to have any offsets. We've already cut this thing to size. For simulation, it's going to look like the grooves aren't in it. And then we need to set our stock orientation. So for this, we would have the holes facing up, facing the mill, and you either want them in one axis or the other. I'm just going to put them in line with the x-axis. So we're going to go to Z and x-axis and select the face. So ideally I'd like the x-axis going in line with the pins, and here's the reason. On a mill, if you have your fixture set up so it's easy for the operator to get to, you don't want any features behind the part to adjust. So in a fixture for the next op, I would rather have it facing so that X goes what is Z in this axis. So it's somewhat semantics, but that's what I'm going to do. And so we need to pick on, I think, a plane that we want it to be normal to, so the top plane. So now I have the x-axis in the mill, which is your horizontal. If you're looking down at the tables, horizontal. Green would be up and down vertical. Okay, so we're going to scroll down and we want to make sure we finish what we're doing here. So we don't want a stock box point, we want a model box point, but top center is fine. You could make it at the bottom, either way. And then I'm going to put in my program name, which is the 101 2, and we're going to accept that. In an effort to declutter the screen, I'm going to go up to my menu here and I'm going to make sketches invisible, so we don't need to see that sketch anymore. We don't need it for the milling. Okay, we're going to change our name to S60-101 op 2 for the mill.